Hey everyone, welcome to our Senses in the Brain curriculum. This is one of the lessons that we normally take around to schools. Of course, we're not able to do that right now, so we wanted to be able to provide it to you to be able to use in your classrooms if you would like to. Of course, there have been some changes. This curriculum has been changed from its original format. It's been formatted to fit your TV or your computer screen or whatever it is that you are teaching on. This is a self-contained lesson, but we have also included links to the activities that we typically would do in a classroom so that if you would like to build on those activities or do anything with them, you are welcome to. So let's go ahead and jump right into Senses in the Brain. So before we start talking about your senses in your brain, let's talk about some of the people who work with your brain and with your senses. This isn't a complete list, but there are a lot of different people who work with different parts of your brain and your body and the way that it functions. So an ophthalmologist is somebody who works with your eyes. If you've ever had to go get glasses or contacts, if you have ever had a problem with your eyes, you probably went to go see an ophthalmologist who is able to do things like scans, make sure that your eyes are healthy, tell you what your vision is like, and give you any corrections that you need. An ENT doctor is a little bit tricky because a lot of times it sounds a lot like EMT, which is an emergency medical technician, but an ENT is an ear, nose, and throat doctor. So everything that's behind your head, your nose, your ears, all of this stuff is connected right behind your face. So an ear, nose, and throat doctor studies all of those things so that they can have a comprehensive view of what's going on behind your face. Nurses, students are typically pretty familiar with. Nurses have specialties just like doctors do. So you might have a nurse who specializes in mothers and babies. You might have a nurse who specializes in working with people who have mental illnesses, things like that. Researchers and professors, of course, are still studying the brain. We're still learning a lot of things about the way that our brain works. There was a common misconception a few years ago that humans only use about 10% of their brains. We know now that that's not true. Typically, we don't use our whole brain at once, but we do actually use all the different parts of our brains, and we know that because researchers are constantly learning new things about our brains. So the information in this video is as up to date as we know how to keep it, but 5 years, 10 years, 20 years from now, we may find that the things that you're learning today are actually not true at all. And that will be because we have updated our science and that we've learned new things. Psychiatrists and counselors are similar, but there are some differences. Both psychiatrists and counselors look at the way that your brain works, the way that it makes you think and feel, and who you are as a person. A psychiatrist is someone who has a medical degree, so they can give you diagnosis and prescribe medication. They can work with your doctor to come up with different plans for different things that are going on in your brain, whereas the counselor is more focused on helping you understand your brain and make choices that are going to be the choices that you want to make in your life. So with all of those different fields, it's no surprise that our brains are actually pretty complicated. This is a diagram of your brain. I also like to use my hand to make a model, and that helps me remember all the different parts of the brain. So here you can see the kind of gray part at the bottom is the brainstem, okay? So that is gonna be like your wrist right here. It connects your brain to your spine and all the nerves in your body. So if you reach up behind your back, you can actually feel a little bit of your spine. You can feel kind of the knobbly parts. And then if you reach behind your neck, there's like one big knobbly part that really sticks out, okay? And then if you reach up above that, you can kind of feel like where your skull starts to get really hard. Somewhere around that area is where your brainstem is. So if your arm is your spine and your wrist is your brainstem, that makes this part right here, the heel of your hand, like your cerebellum, which is the blue part. Your cerebellum is responsible for your coordination and for keeping you alive. The only thing your cerebellum cares about is you staying safe and you staying alive. So if you have ever been walking down the street and you go to cross the street and suddenly you see a truck coming and you jump out of the way, that's your cerebellum noticing that something is dangerous and moving you out of the way. Okay? So now take your thumb and fold it over like this. That is like this green part right here called the temporal lobe. It's responsible for hearing and facial recognition and short-term memory. So then if you flip your hand over, the back of your hand right here is like the occipital lobe, which is responsible for vision. So if anyone's ever fallen and hit their head before, what happens is your brain at the very back of your skull hits the back of your skull, and that impact might make your vision go a little bit blurry or a little bit dark for a second. That's how we That's one of the early ways that we knew that this part of your brain controls your vision. Okay? So then, right here you have your knuckles, which is like the parietal lobe. It is responsible for touch and pressure, taste, and body awareness. So your ability to taste things, your ability to sense what you're touching, hot and cold, how much pressure, things like that, all of that is controlled right here. Then if you take your fingers and you fold over like this, that is like your frontal lobe. This is my favorite part of the brain. It is the part of your brain that makes you a person versus a baby or a monkey or anything like that. If anyone has a favorite color or a sense of humor or friends, things like that, all of that stuff is controlled up here in your frontal lobe. Motor control, concentration, problem solving, your ability to speak and your sense of smell, all of that is controlled right here. One of the cool things about your frontal lobe is that it actually doesn't stop growing in until somewhere between 18 and 25 years old. So your ability to make decisions and to concentrate on solving problems and know what kinds of things are going to happen if you make certain decisions, that is not totally developed until you're well into adulthood, which is one of the reasons that kids aren't allowed to do things like vote or drive a car, because this ability hasn't really come all the way in yet. All right, so let's talk a little bit about your eyeballs. Most people have two eyeballs. That is kind of the standard for humans. And the reason that we have two eyeballs is so that we can have what's called stereoscopic vision. So basically the way it works is that your left eye sees something and your right eye sees something, and then dependent on how different those images are, your brain figures out how far away things are. Okay? Humans have this ability because we are predators, and that means that we are capable of chasing down and hunting other animals, right? Animals like deer and rabbits and things like that, they have eyes on the sides of their heads. That gives them a wider range of vision, but they can't judge distance as well as humans can. If you want a really quick and easy way to prove this, you can do what's called the Frankenfurter illusion. This one's kind of tricky, so try it a couple of times if you need to. If you have glasses, take them off. What you're going to do is you're going to take your fingers and you're going to touch both of them to the bridge of your nose right here like this. Then you're going to pull them out just enough that your eyelashes kind of still brush your fingers. And you're going to stare not at your fingers, but at the wall beyond. So I'm looking right into the camera right now rather than focusing on my fingers. And I'm going to start pulling them apart very slowly until I start to see one floating finger right in the middle. Okay? You need to try that again. Go ahead and try it again. If it's not working, your fingers may be like too far away from your face, or they may be too close, or you might be focusing too closely on your fingers, right? Make sure that you're really focusing beyond. Okay? So what happens is your left eye sees something and your right eye sees something, and then your brain tries to put those two images together, but because they're so close together, what your brain sees is one floating finger right in the middle. Okay? Another cool thing about our eyes is that we actually see everything upside down. So if you've ever seen a projector before, it's kind of similar. The way that we see is that light bounces off of objects, and then the light comes into our eyes, and our brains interpret the patterns that the light makes on the back of our eyeballs. So in this slide, you can see there's a picture of an apple. And as that light enters the eyeball, because your eye is round, it's convex, it comes in and it flips the image upside down and it projects it onto the back of your eyeball the same way that a projector throws light onto a whiteboard. And then your brain looks at that image and it says, no. I know that that's not right. I know how gravity works. And it flips the image back upside down. There was actually, you know what? Let's do an experiment first. So one way to prove this really easily, again, if you have glasses, go ahead and take them off. If you're squeamish about eyes, don't do this experiment, and also be very, very careful. It's going to be a little tricky to take anyone to the hospital right now if they poke their eyeball out, so please be careful. Go ahead and take one finger, and you're going to place it just at the corner of your eye like this. Okay? So do you see how I'm not trying to touch my eyeball, and I'm not like clear over here, and I'm not like right in the middle of my eye. I'm right in the corner of my eyeball, and I'm going to press very, very gently until I see a dark spot in my vision. Go ahead and try that out. Now you'll notice that the dark spot is not where you're poking. The dark spot in your vision is actually opposite. So for me, the dark spot in my vision is like up there somewhere. Okay? So that's a really easy way to prove that everything is actually upside down, right? So because I'm poking the bottom of my eyeball, the top of my vision has that dark spot. And if I do the other side, same thing. It's like right over there. Okay? That's a really easy way to prove that everything we see is upside down. So there was a researcher, let's go back. named George Stratton several decades ago, who wanted to know how long it would take your brain to adjust to being able to see things upside down. So he made a pair of goggles that put everything upside down. One question I get a lot is, if you put the goggles on so that you see upside down and then you flip upside down, would everything be right side up again? Yes, but it's still pretty confusing for your brain. So he wore these goggles every day and every night for about 2 weeks, and by the end of 2 weeks, he had kind of adjusted. His brain had figured out, okay, I'm seeing everything upside down, this is what right side up is, and he'd fixed everything. And he said, great, awesome, perfect, I finished my experiment, and then he took the goggles off. And when he did, he realized that it was going to take another 2 weeks for his brain to adjust to being able to see everything correctly again. So our brains are really cool. They can adjust, but some things take longer than others for our brains to be able to adjust to. So let's talk a little bit about colors. A lot of times I ask students how many colors humans can see, and the most common answer I get is people doing this, just like hundreds and thousands of colors, okay? But really, humans can actually only see about 3 colors. So here you can see we have a diagram of our eye, right? And around the outside of your eye is a thing called a cornea, okay? So that's this outside layer right here. And in it, you have special cells that are designed to be able to take in light. Do you remember when we talked about how light bounces off of objects and then it hits your eyes, and that's how you know where things are? These special cells are what take in that light. So you have cones, which are these kind of triangle-shaped ones. They look kind of blue in this picture, but they should be black. Cones only see in black and white. They don't see any color at all. So if you've ever been like awake in the middle of the night in your house and it's really, really dark, and you can kind of see shapes, right? Like you can see where things are, but you can't see really, really clearly. That's because cones work really well in low light. They can only tell, is there light there or not? So you can see objects, but you can't see color very well. And then you have what are called rods. They're longer, thinner, and they're designed to see color. So you only have 3 rods. You have red, green, and cyan. So the way that we see all of the different colors is by putting those colors together. So if you see cyan and red, you're probably going to see your brain adjusts and says, okay, on the spectrum, it goes red, orange, yellow, green, blue, purple, or violet, indigo, violet. There we go. If you see some red and some green, your brain goes, okay, there's some overlap there, and in that overlap is orange and yellow, so it's like kind of orangey. There's like more red. Or it might be like, you know what, it's pretty yellowy, so like there's more green. Your brain interprets the overlap of the colors that you're seeing and says, okay, I know where along the spectrum of light that color is, so I'm gonna guess it's about here. Dogs can see in 2 colors. I believe they can see red and green. I'd have to double check that. But so they can't see cyan the same way that we can, but they still can see some colors. This little animal right here in the corner of my screen is called a mantis shrimp. Mantis shrimp have 12 cones. They can see not only all of the colors of our visible spectrum of light, they can also see ultraviolet and infrared light. They see those as colors, which is something that humans can't see without special technology. So that's pretty cool. Let's do a quick little experiment about the way that your rods work. So I have a picture up here on the screen. Go ahead and stare at that. We're going to stare at it for 20 seconds, all right? You can blink, but don't look away, starting now. So keep staring right at that star in the center. Like, just need 10 more seconds. 9, 8, 7, 6, 5. Now keep your eyes right on the screen. Don't move them at all. All right, what do you see? If you didn't see anything, you're welcome to rewind and try it again. Sometimes it takes a little bit longer, so if you want to pause and just really stare at it for a while, you can. But if it worked correctly, you probably saw the American flag on this white screen. So the reason that happens is as you're staring at this image, the rods in your eyes get tired. So this kind of yellowy color in the top left-hand corner, the rods that are taking in that color get tired and they compensate, and your brain says, okay, you know what, tone it down a little bit, make it the opposite a little bit. And the opposite of this color is red. If you're looking at these black stripes, of course, the opposite of that is white. If you're looking at these bluish, these like teal stripes, excuse me, I got those mixed up. The yellow is opposite blue and this teal is opposite red. So your brain adjusts and says, okay, make it a little bit more red so it's not making my eyes as tired. And then when it switches all of a sudden, your brain still has all of those adjustments, and so you see the American flag, which is pretty cool. Okay, so let's talk a little bit about our brains and hearing. There is a very cool video that I'm going to link right now, so go ahead and take a look at that first one. It's called Auditory Illusions. I will wait here, open it up in a new tab, watch it, come back, all right? It is a very cool experiment about the way that our brains listen for different things and the way that they'll totally ignore information that we don't think is important or don't want to hear. So go ahead and do that now, come back, and then we'll talk about it. Okay, so how well did you do in that illusion, right? There are some things that you look at and you're like, oh yeah, I totally know what that is. And then as soon as you take out the sound or as soon as you close your eyes, you realize that what you're hearing is actually very different because your brain really wants to take all of the information it's getting from all of its senses and put it together to make one whole picture. Okay? All right, so let's talk about our brains and memory. This one's kind of cool. There was an experiment done a few years ago. That's not what I wanted at all. There was an experiment done a few years ago where a man had a disease in his brain, and the doctors figured that the only way to get rid of the disease was to take that part of his brain out. So they did. They took it out. It cured the disease. It was really successful. And then they noticed a couple of weird side effects. One of the things that they noticed was that he kept eating meals over and over and over again. So he'd have lunch, and then like 10 minutes later, he would have lunch again. And it took him a long time to figure out that when they took out that part of his brain, they took out his ability to turn his short-term memory into long-term memory. So he would eat lunch, forget that he had eaten lunch, and because it was taking a while to digest the food, he would still feel hungry, so he would eat lunch again. And he kept doing that over and over and over again until he started to feel full. So they finally came up with a plan, and anyway, he ended up being just fine. But that is how we learned that our short-term memory is controlled in this part of our brain right here, if you remember our model from earlier. So we are going to do a fun little game. So this is a face memory game. Okay, so what we're going to do is I'm just going to play it a couple times so you get the sense of it. The link of it is right up here in this bar right here, so you can try this out on your own. It's totally free. You don't have to download anything. So the way that it works is you click start and it scrambles and it makes a random face. So when you're ready, you hit play. And you're going to try really hard to memorize this face. So I'm taking a look at it. I think I've got everything. And now that I'm ready, I'm going to click ready. And now I have to figure out all of the pieces that were in this face. So I'm pretty sure it was that one. Ooh, I actually don't remember. Maybe this one? Was that one? It's the same on both sides, though, I think. Ooh, I think that looks right to me. That one's for sure right. As is that one. I think it was the pig nose. We'll double check. That looks correct to me. And then when you think that you've got it, you're going to press OK. And it's going to tell you how many you got. So it says I got 9 correct. Let's see what I missed. Okay, I missed one eye. So the more times you play this game, sometimes the easier it gets, sometimes the harder it gets. It just depends. Some people find that their memory of them blur together, and some people find that as they get used to the pieces, they can remember which ones they are better. So one of the other really important things that our brain does for us is solve problems. And it has a lot of different ways of doing that. In fact, a lot of different parts of your brain are going to solve problems differently. Do you remember at the beginning how we talked about this part of your brain is only interested in keeping you alive, and this part of your brain is what helps you concentrate and solve problems, right? Sometimes some problems need to be solved really, really fast, right? If you step into the street and you see a truck coming, that's a problem that needs to be solved right now. You don't need to concentrate on that, you just need to get out of the way. But if you're taking a test, you probably need to concentrate to be able to remember all of the things that you learned. So there is another video that I have listed below, and go ahead and take a look at that. And then when you're done, come right back and we'll talk about it. So go ahead and do that right now. So you noticed in that video that there are some times when thinking really fast helps you out a lot. And then there are times that thinking fast can trip you up and make you make mistakes that otherwise you wouldn't make. So it's really important to learn how to ask yourself, do I need to think fast or do I need to think slow? And thinking slow isn't a bad thing. That just means that you're using this part of your brain to solve a problem rather than using this part of your brain to solve a problem like that. Okay? So there are some activities that we typically would do at the end of this lesson. I've included a link to the description of those in the bottom. But that is the end of the lesson. So just as a reminder, some of the careers that we talked about in the beginning of this lesson were an ophthalmologist who works with eyes, ENT doctor, which stands for ear, nose, and throat. Nurses, which we talked about, would have sometimes have a lot of different specialties. Researchers and professors, psychiatrists and counselors, and even more than these, there are hundreds, if not thousands, of jobs that work with your brain, your senses, different parts of your body, doing different kinds of research. So if this is a thing that you're interested in, there are a lot of different options. If you're interested in how much money those people make, I have pulled up right here the average salary for those people in the state of Utah. I don't know about you, but I would love to make $126 an hour. That would be pretty cool, I think. And in order to do that, there are some different things that you have to do. Obviously, if you're going to work in any kind of field of medicine, you have to do more school than just finishing high school. If you want to stay in Utah, here are just some things that you can do. Brigham Young University has psychology, public health, nursing, medical laboratory science degrees. Weber State has emergency healthcare services, health sciences, nursing, pre-optometry. Optometry is, your eyeballs. University of Utah has health promotion and education if you want to teach people about that. They have nursing, biology, psychology. Southern Utah has a nursing pre-licensure if you live down near that way, or if you want to go to school down there, they have a pre-medical program. Utah Valley has a nursing program. So there are a lot of different things that you can do that are right here in Utah that you don't have to leave the state to do. So if you have any questions, you can send us an email at steminmotion@utah.gov. If you want to see any of our other curriculum, let us know. We're going to be working on getting some of those things up and ready to go in the future. And then if you have any questions that I can't answer for you or that are more related to the way that your brain works, of course, always try to look them up. Being curious is part of being a scientist. But if you can't find them online, you can also talk with your school counselors. You can learn more about medicine from places like Khan Academy, Crash Course, ASAPScience, which is where those videos that we watched are from. So remember, have fun, stay curious, and we will see you later.